Today, we're going to talk about data onboarding and how you can make that process more efficient. So first, let's get on the same page with respect to vocabulary. By onboarding, I mean the process of bringing in data from some outside location into some specific well-known system or process. Most common example is when you operate a business where you need to take data from your clients or customers and move it into your system or platform where you can operate on it and presumably return something of value. Perhaps some complex analysis or a report. Perhaps you turn around and provide your client with a new way to access and operate on the data that you're onboarding. Maybe you're switching clients onto your proprietary platform. So we're most often talking about data from a new client, or actually really from many new clients. It might be a one-off onboarding exercise where you take data one time, or maybe a regular process where you need to take data from your client on some sort of recurring, continuous basis. For the sake of discussion today, let's focus on the idea that you want to onboard not just one, but potentially many clients. So we want a repeatable onboarding process and a process that can easily adjust to subtle variances between how you handle individual clients, right? And I'll be using onboarding and ingestion, I think, interchangeably as I go through this talk. There are some overarching goals when you build an automated onboarding process. Probably the most basic goal is reducing any burden on your client. Excuse me. We want the process to be as easy as possible for the new client. We don't want to force them into providing data in some specific format. We want to remove as much as possible any obstacle that prevents or slows down adoption. Ideally, we can tell our client, hey, just give us the data in whatever format's convenient for you, and we'll figure it out. We also want to create a process that can be operated by less technical staff. We want a simple process that can be operated by anyone, not just a developer, programmer, or someone with some deep technical savvy. We want the process to be resilient so that it can handle minor variations in incoming data, again, without having to reach out and get help from some development organization. We want a complete process, one that handles the onboarding from start to finish, from detecting the arrival of files to be processed all the way through to loading the target system. We want some robust reporting that provides actionable intelligence when errors occur, of course, but also reports that describe successful executions as well. And then we'll want to use any of these kinds of reports to support retries, to fix issues detected in one run and to quickly retry and run again. And then finally, we want a reusable process. The ideal here is a single generic data pipeline that can be used for every client, as opposed to creating a new copy of the process each time you want to onboard a new client. So I have three real-world examples of frameworks that automate the data onboarding process and at the same time achieve many of those objectives. First case is from the legal domain. We have a process for onboarding new clients onto a commercial legal case management system. From the education space, we have an onboarding process that collects daily operational data from individual schools that can be used for analysis and reporting. And then in fintech, we have an onboarding process that manages ingesting data about consumer debt collection. So 3 cases here, each are going to help us, explore some of the objectives of a good, solid, automated onboarding process. Each is also implemented using our CloverDX data management platform. But the objectives and principles, I think, are going to translate to any tech stack that you might choose to build your onboarding platform. So allow me to take 1 minute to describe the platform, the CloverDX platform, so my discussion of some of these use cases will make a bit more sense. CloverDX is our data management platform designed specifically to build and operate data pipelines. It can be used to replace or augment any legacy systems you have. It can handle some fairly complex data scenarios and deal with messy data, which is, probably the most common challenge when developing onboarding pipelines, right? So we encounter messy data a lot. This platform is very good at dealing with that. The platform itself has 2 pieces. You can see in this infographic on the lower right, there's a design piece, right, that allows the visual development of a data pipeline, of an onboarding pipeline. So you can do this with sort of a low code environment. And I'm going to show you a number of screenshots that come out of our design environment so you can get a sense of what the visual look of a data onboarding pipeline looks like. But then the other piece of our platform, called Server, handles the automation so that the data onboarding pipelines can run automatically and unattended. Together, we can use these 2 pieces of our platform to connect to almost any type of data, onboard it, transform it, shape it, cleanse it, and then write it to almost any target. Right? So with that quick intro to the platform, let's get into these use cases. Case 1, as I said, is onboarding clients into a legal case management system. Our client builds and sells a case management system. They want to minimize the switching costs so that their new clients have a simple, fast way to move their operations onto this new platform. Right, so for this client, specific objectives need to handle client data in a variety of file formats, want to land that data as it comes into some staging tables in a relational database. We want the process to work without any, advanced knowledge of the incoming data file formats, right? Instead, we want the process to inspect the incoming file and auto-detect or determine what the structure is, and then use that structure to actually read the data and populate a stage table, essentially with the same structure, right? That's what we're doing really, if you think about it, is creating a data lake where we have relational representations of all of these incoming files, and then a downstream process can do some further ingest onto the platform. And then finally, an objective here is that we want to simplify retries or reloads, right? If the first onboard process, if something goes wrong and the data doesn't land correctly, we want to be able to make quick adjustments and rerun the process again without help of some development team, right? So from a business flow chart, right, the onboarding process is fairly simple, right? Fetch the files that need to be onboarded, determine what their structure is, create the target table in the database, load the data, go ahead and archive that ingested file, and update some log so that we can keep track of what files were ingested. That's the base, business process for this particular onboarding case, right? And here's that looks like in CloverDX Designer, right? So this is actual screenshot from our design tool. This is actually, while it's visual, it's actually executable code that will do these steps, right? List the incoming files, create the metadata, do the inspection and figure out what the file formats are, use that new metadata to create and load the table, and then update a log. So you can see essentially how our data pipelines can be visually designed and closely respect the original business flowchart. Right? If we go back to that business flowchart, there was some additional complexity that the client wanted in terms of being able to support logging of the process and supporting retries. So here's that same business flowchart. You can see the blue components still there, but I've added some new red components to describe that additional logic, right? Fetch some files to onboard, but then first is to check, have we already onboarded this file successfully? If so, we can skip it. If not, then the question is, well, have we already guessed at what the structure is? Or do we need to do that step as well? Maybe we have already guessed what the metadata was on the previous run, but we guessed wrong. And so we've made a subsequent change to the metadata by hand. And so we can skip that step now. We no longer have to determine the file structure because we did that once before. We had to tweak it and rerun. So we skip that step. We can jump straight into creating the target table, loading the data. We want to check for success. That's a new step. Log those errors so that we can retry and have that retry sort of inform the metadata, right? The errors that we log are going to suggest, well, we guessed wrong at the metadata. Let's try it again. We'll manually tweak the metadata, simply rerun the process again. And you can see how you can sort of quickly iterate over the process until finally all the files that we need to ingest have been successfully ingested, right? So this additional logic supports that ability to do retries. And we can see that same logic back in the actual real pipeline, right? Here was our first pipeline, our base case up here in the dotted area. You can see those components still exist in the red here, but we've enriched now to build our actual real executable pipeline to have this logic, right? Have I already processed the file successfully? Then I can skip it. Have I already generated metadata, or do I have new metadata that I've tweaked from the previous run? Then let's skip that metadata generation step and just move straight to load. Right, so very straightforward to map what was a business data flow provided by the customer into an actual executable pipeline. All right, so highlights on this particular use case. The error reporting, as I mentioned, that's important, not only for failed ingests, but successful ingests. So here's in this case, our pipeline logs to an Excel spreadsheet, just to make things simple to look at. I know when a particular run started, how long it took, what file was ingested, how many records were created, how many were rejected. Another tab on the error report lists, if a file fails, the reasons why it failed. I can take those errors and use that to inform my retry. And my retry is simply just changing the metadata that the pipeline auto guessed, right? The pipeline guessed at the metadata. If it guessed wrong, that metadata is in a text file. I just need to go in, look at that text file, maybe make some more intelligent changes, and then rerun the pipeline. It'll skip the auto generation, and we can retry very quickly without needing to change the pipeline itself. Okay, use case number 2. That's from the education space, K through 12 schools. Here we're onboarding operational data from each client school. Things like enrollment, class schedules, contact information, attendance is probably the most dynamic data. And then that data is used to provide schools back a portal where they can share information with their with their constituency, most likely the families or people interested in the operations of the school, right? This data is actually onboarded continually, with schools sending updates multiple times a day via FTP, right? Incoming files, incoming data is pre-processed as necessary and then pushed into their portal via an API. So the target, in this case, the target system for our onboarding is an actual API call to push data into their portal. This client came to us with the system already in place, written custom in Python, but being operated by a non-technical team that took care of the daily, care and feeding of the pipeline. And it was a challenge for them to maintain and to add new schools without the help from the original developers of the system. So they had some objectives, right? They wanted the new automated pipeline to monitor an FTP site and detect when files arrive. Also wanted to monitor an email box for those same types of files. Wanted to orchestrate the entire process from the original detection of the files on the FTP through unzipping them, doing sanity checks, quality checks, any sort of transformation that might need to occur before pushing to the API. So they wanted to orchestrate the entire process and while at the same time handling school-specific special cases, all without, creating a new pipeline every time they had a new school, right? So they wanted a reusable pipeline that could be easily maintained by existing team, and one that didn't require building a new pipeline every time they had a new school to onboard, right? Wanted to make a nice reusable pipeline. Business data flow again. Looks similar in some cases to the first one. Get those incoming school files from FTP. Confirm if the files are the ones that we expected. Each school is going to send us a different set of files. Perform some data quality checks. Some schools have some optional transformations that need to be run before we can push into the API. Then finally push the data into the API and again update an ingest log, right? So that's the business process as it was described when we began the process of building the automated solution. They also had that alternate input source, as I talked about. From time to time, a school, instead of putting the files on the FTP, just sent them in email, right? So we needed to monitor an email box for some data to onboard. And what we simply do there is monitor that email box. If new files arrive via email, well, then just push them into the FTP, and then you can start the regular process as it was originally designed, right? So we built an onboarding, end-to-end onboarding solution that handles, both of those cases, right? The base case, FTP triggering, again, looks familiar to that business flow chart. We're going to monitor the FTP site, grab files, skip the files that are not of interest, remove any duplicate files that might have appeared. Sometimes the school would upload the same file more than once if they're doing uploads multiple times a day. And then process the individual school files and create those logs, right? All of this driven by configuration files, right? We want this to be operable and configurable and controllable by non-technical people, right? And so, apologize for the typo there. We want configuration files for each school. In this case, we chose Excel. And so for each school that we onboard, we have an Excel file with a couple of tabs, right? First tab, as you see down here in the lower left, just describes the files that we're expecting from that school. They may be zipped or they may just be in a directory, but when the school uploads, they said, look, these are the 4 files that we intend to provide. And we've got some data quality metrics in there, right? Just to make sure that things are going carefully. We're expecting, between 600 and 800 students in the students file, between 10 and 40 teachers in the teachers file. So if we can do some sanity checks on the onboarding process and kick back files if there's a reason to be concerned, right? New school comes along, simply add a new Excel file and drop it into the configuration directory. The single generic pipeline will pick that up and process it. All right. The second tab in the school specific configuration file describes any optional business rules or transformations that need to be applied for data from that particular school. All right. So in this case, this particular school had 2 transforms, one that strips out potentially bad characters that might appear in the files that they generate, and the other that does some logic to strip down an attendance file to just the most recent entry. All right, so the config file has the list of optional transformations to run for this particular school, whether or not they're enabled or disabled, so we can quickly turn these things on or off. And then it's actually an active configuration file. The system itself will go ahead and tell you, well, the last time we ran this transformation was on such and such a date, right? Each of these rule sets in the transforms section of this config file can be associated with some segment of the pipeline, right? So here, down at the bottom, here's a pipeline segment that can be optionally run for some particular school that might take the attendance file, just strip it out to strip out the records in it to just get today, and then go through period by period and just get the latest attendance for a particular student, and then use that to push into the API, right? So this is a segment of the onboarding pipeline that is optionally run for a particular school, right? The overall pipeline structure stays the same. This segment is something that's optional and can be easily turned on or off by the team that's operating the pipeline. I mentioned email triggering earlier on. This is what the pipeline piece looks like for that, right? This is sort of that preprocessor up front, right? Pipeline that looks at an email box, finding emails that have a particular subject and also have attached files. If it meets both those criteria, join them up, push the resulting email, those attachment files onto that FTP and send back an email to the school saying, hey, I know this is sort of an out of band request, but we received it. We've got your attachments. They're in the queue. They're ready to go. All right, so very easy to translate those business requirements into an actual data pipeline design. Again, this represents executable code. Although it's a visual design, it is the actual design of an executable data pipeline that runs on the CloverDX platform. And then finally, and this is probably a little small to try to read, but the point here is the entire end-to-end process is orchestrated, right? So this is, I had to break this screenshot into many pieces, but it's the entire orchestration from detecting files on the FTP site to unzipping them if necessary, to checking against the config file to make sure that, this is Springfield Middle School and Springfield Middle School promised us these many files. Yes, those files are present. To actually do those data quality checks on each file, then to go off back to the config file to say, oh, well, are there transforms that need to be run for this school? If so, grab them and execute them. And then finally take those finished, quality assessed, transformed files and push them into the final API that drives the client's portal, logging the success at the end. So we have an end-to-end orchestration of the entire onboarding process, right? Highlights here in use case 2, we think is that configuration file driven approach where you can specify QA metrics and the any optional transformations. We have multiple targets. I didn't really mention that, but we take that data, we make API calls to push the data into the portal, but we also take the data files that we've created and put them into an S3 bucket for archival or for subsequent, auditing or any sort of deeper analysis that might need to be done on historic data that was ingested into the system. And as I mentioned, full orchestration, right? The entire process end to end is orchestrated and automated through a data platform. Okay, last use case, case 3, comes to us from FinTech, deals with consumer debt collection, right? We have a platform that's used to outsource the collection of debt. So in this case, a client of this service has customers that need to have debt collected. When that's the case, the client can simply upload information about that debt to the platform. That data is onboarded on an ad hoc basis, right? There's an initial onboard when where a customer joins the platform and say, hey, here's a list of all the people that owe me money. But then that's often followed by incremental uploads as the list of debtors or their status changes, right? So they had some specific objectives for their process, right? First of all, it's a highly competitive business, debt collection. So the onboarding process really has to be as simple as possible, right? Don't want to force specific rules or data formats on the new customer. Just give us your data and let the platform figure it out, right? That removes any sort of barrier from acquiring new customers for the platform. Likewise, tolerate variances in data formats, not only between clients, but also between week to week for a given client, right? As a client, someone becomes a client, and then 3 weeks down the road, they give you some new information about new debtors, and it's in a slightly different format, right? We want to be able to tolerate that without having to stop the presses. Obviously, want to onboard as quickly and cost efficiently as possible. We want this really to be a no friction, highly scalable, so that we can get clients onto this debt collection platform as quickly and as cost effectively as possible. And then we want it to be operated by, again, an empowering non-technical team to operate the platform and to keep it running. In this case, again, we're going to use Excel configuration files to make that happen, right? Business flow, again, by now, case 3 should look fairly simple, right? Although these are real cases and come from real clients, the similarity for onboarding is there's a lot of commonality here, right? Fetch those incoming files from the FTP, determine what kind of file it is. In this case, the clients can send, hey, here's a list of new people I'd like to collect debt against, or here's a status change for some people that you already know about, in terms of the amount of money we need to collect, or here's some people you can stop doing collections from. So 3 different types of files that a client might provide. So we need to figure out what type of file that they've given us. Then we need to go look up the specific mapping and transformation rules for that client and that file, and then use that to actually do the read and transform. In this case, the target is taking the transform data files and pushing them back up to the FTP site where the actual indebted platform now has files in the format that it expects them to be in, and update the log file. Up top here, another sort of ad hoc way to run the pipeline. This was important. Not only do they want this automated fetch from FTP and automated detection, they wanted to be able to manually operate the entire flow from a web application, right? So do some onboarding automatically, but also do some onboarding ad hoc via web app to say, hey, here's a new client, here's his new client, here's his debtor list, and here's the mapping file, right? So instead of injecting them in the system, just provide them via a web app. So we can skip those first 3 steps, dump straight into the pipeline here. All right, so that's the business process is provided to us as we begin design of the platform. Probably the most interesting thing really is the design of these configuration files, right? And so here is an example of that. Again, Excel, because it's easy for these non-technical onboarding teams to operate with. So here's the instruction file for a particular new client of this platform. 3 tabs, each describes the data that we're going to receive from that client. The case tab is like, okay, here's a list of new people to go chase debt from. Activity is just a list of changes to existing people, like this person now owes us more money or less money. And then closures, like stop bothering, don't try to collect from this particular individual anymore. So 3 different types of files that the platform would accept from any client. For each file, we have a structure that looks like this. The first column, this is just the name of the fields that we need in our system, right? So the fintech debt collection system that we're onboarding onto, it needs these 16 pieces of information about any person to collect debt from, right? These are the fields that the system needs. The middle field, or the middle column, describes the mapping from this particular client, right? So we're going to expect, this says we expect the client to provide a file that has field names that match these square brackets, right? Address 1, we expect it to have a field called address 1, a field called address city, and this is how we're going to map, right? The conversion doesn't care what order these fields are in. It doesn't care if there are extra fields. It doesn't care if some fields are blank. All it needs is a field called email someplace in the incoming file, and we'll map that to our contact email field, right? So non-technical team can come in, a new client needs to be onboarded, create a new version of this file, of this config file, review the file that the client has sent, and figure out which fields map to our fields, and just define them in this spreadsheet, right? Occasionally there needs to be a transformation run. Those are represented in red. Maybe we want to convert a date. The date is coming in their incoming file in a particular format. We need to make sure we get it into a more specific format for us, right? But this is the kind of file that a non-technical team can create, right? They don't have to change the data pipeline. They don't have to write code. All they need to do is open up a sample of what the client intends to send and do the mapping and define that mapping in the spreadsheet. Once that's done, the pipeline that's developed will consult this spreadsheet to do the mapping, right? That will all run automatically. If you do need to do some reprocessing or some one-off processing, well, we can provide a web application that will accept all of this information sort of out of band instead of, through the standard FTP process, right? So the onboarding team can simply open up this web app, specify the name of the client that we're onboarding, specify which kind of file. This is a new client file. Actually upload the actual file, and then upload the config file that I just showed you. Upload this file as well. So you can quickly create a one-off version of this file for a specific data file for a client, come into this web form and invoke the standard data pipeline, but with a special input file and a special set of instructions, right? So that makes it very simple to do reprocessing or ad hoc processing, all using the same base case pipeline that is out there running automatically using the FTP. All right. Rich logging, again, always important. Here's an example. Every file that was detected, whether it was via the FTP or via the web form, when it ran, how long it took, what client it was for, what file type it was, what the actual input file name was, what the actual output file name was, how many records we detected on input, how many were actually processed, how many were rejected. So we have a very rich log of all of the executions for every client and every file, right? Which is very helpful going back to analyze performance of the system, but also to debug any issues that a client, if a client says something went wrong, we can go back and say, well, here's the file that you sent on such and such a date. And this is how many records we pulled out of it, right? So lots of uses for a rich log to this onboarding process. Highlights on this use case, I think most importantly, is that configuration file and how easy it is to allow this non-technical team to quickly onboard new clients without having to go back to a development team or having to go back and actually look at pipelines, right? Just build that configuration file. And if you need to run things initially, use that web application, or if you need to run things out of cycle, or if you need to just reprocess a few records, you can create a quick copy of the config file, a quick copy of the corrected records file, and run the pipeline on demand. The configuration file, as I suggested, is really clever in how it tolerates variations in the input file. If the client sends us a list of people we want to debt collect, but they change the format, that's fine. As long as those key fields are in there in any location, we don't care what else is in the file, and we don't care what order they're in. As long as we can find those fields, we can be resilient and process that file without having to go back to them and say, hey, you accidentally changed the format of the file. All right, we don't want to do that. We want to be as invisible as possible on this and be tolerant of what we accept. Right. So those were the three cases that actually represent real world examples of automated onboarding processes. You probably hopefully have seen some commonality, some common themes across all three of those, right? End-to-end orchestration, being able to not just do a piece of the process, but to make it a completely automated, unattended process to allow new data to be onboarded to your system. Being able to handle variations in input, being very lenient in what we accept without having to stop the presses and go back and clean things up or burden the client with, sorry, please, can you change the structure of what you're sending us, right? To do that end-to-end orchestration and to handle those variations with a less technical team, right? By making it configuration file driven, by providing alternate sources or alternate ways to control the pipeline, specifically with, in our example, with web application controllers. And then robust reporting. That reporting is good to manage the system so we know how onboarding is doing. It's good for retries so that we can quickly identify errant data and get it recorrected. And then just giving us an overall health of our business by knowing how the onboarding is going. So that reporting can serve a lot of purposes, both client facing and internal to the business. So important that these onboarding pipelines collect data about their operations at all points along the pipe and then report that back